I think we have a complete disregard for our environments.
Water's drying up, which is kind of silly because it rains all the time everywhere.
35 to 38% of the greenhouse gases are produced by just 5 materials.
सरकार हमेशा बहुत अच्छी स्कीम्स लाता है, बट वो लोगों तक नहीं पहुंचती है.
There's so much research around solutions, so where is that gap?
We have found more than 25 ways of building earthquake-safe buildings without using cement.
What will people pay for? People will pay for design.
We thought of coming up with a model solution that can be easily replicated.
With analytical tools available, it really makes sense to use data to optimize design.
We're facing a climate emergency, but it's not irreversible if we act swiftly and decisively.
I wanted to build an Uber for waste. Every bit of waste is a resource.
The footprint of this project is hardly 20% of the entire site because the unbuilt is as important as the built.
Very quickly I learned that the person making the big decisions was the person who is controlling the money.
I think adaptive comfort has to come back into picture.
You have to talk to the people. If you want the project to reach somewhere, you have to involve them in the process.
अगर कोई बहन एम्पावर हुई तो वो बेनिफिट पूरे एंटायर फैमिली को मिलेगा.
Tiling industry is massive. Even if you change 10% of it, there's a huge carbon emission saving that we would do.
Now this is suddenly sustainability that is offered not at a premium.
Disruption can bring the world to its knees, but it can also breed innovation. Building materials and the process of construction currently account for 11% of global carbon emissions. As the world's population approaches 10 billion by 2050, this percentage is expected to rise sharply. This means that finding alternative building materials and processes is critical to decarbonizing the building industry. Our guest today is Carbon Craft founder Tejas Sidnal, who since 2016 has been working on finding ways to upcycle carbon into building products. So Tejas, what I want to start with today is your journey. You studied to be an architect. How did you land up doing what you're doing today?
Well, it's been an exciting journey. I finished studying architecture back in 2011. But I was always excited about biomimicry, which is learning from nature. How do you really see and build the way nature really builds? Wanted to learn more about it. Went for my master's in London, studied emergent technologies and design from Architectural Association. Wanted to practice it, so I went to China. I was practicing as a parametric architecture specialist. So learning to use these tools to see how we can create these facades or buildings which are responsive to climate in a way. So learning about that, practicing it, but my soul wasn't satisfied, I'd say. So came back India.
So from building, in alignment with nature or, as nature builds to what you're doing today, which is so focused on carbon. Why carbon?
I think the way we build right now is very energy intensive, which I believe is we can change that in a way. So inherently, if you see the way nature builds, they use local materials. There is resource efficiency in a way, which means that it uses very localized sort of materials to be able to build. The energy that they use is very, very low to be able to make, and it acts as a carbon sink. So there is what they do, and here is what the way we build, and
carbon
intensive, very, very intensive. So how do you really change that narrative and not have buildings as a polluting mechanism, but a way to sink the carbon into? So trying that as a way of building is how the journey really started. You can't make carbon negative homes without having carbon negative products at the first place. So that's where I think we started to see that, is there a way to build products maybe instead of seeing this as a whole, as a building, but start with that one basic element. So that's why I think the building material as a segment, we started to work in that.
So when you start working in the building material segment, I think the first thing you think of is where does the majority of the building mass come from? It's either brick or it's concrete, right? So did you start with, I mean, of course I know that you're working with tiles at the moment, but did you start with, bricks and maybe concrete and cement?
Yeah, so if you see, most of the building in terms of the raw material would use cement majorly. And then it goes into steel, which is energy intensive, right? And if you look at any building material, the energy goes in two parts. One is the material itself. Second is the process of really making it. And the major mass, as you rightly said, is brick as well. So we started with bricks. This is back in 2016. And we thought that, can we really make like a brick which is low carbon intensive or eco-friendly in a way? What we did was we took all the waste material that we could get, started with the C&D, which is the construction and demolition waste. We started to look at all the various waste that we can really get. And carbon was one of it. I had sort of approached a friend of mine to see, can we use the same carbon which he was using to make ink to make bricks out of it?
I think that raises a very important question actually. We know about carbon emissions and we talk about carbon all the time and we talk about it as a pollutant, but where is this carbon? How do you capture it?
So carbon essentially is everything black that you see around you right now. This is carbon black. Anything black. It could be any laptop that you're using to watch, the phone, rubber. It could be this chair, absolutely anything.
It's carbon black. Carbon.
It's made out of carbon. So carbon is carbon black as well, which is a technical name. And that's made by burning fossil fuel in a controlled environment. That's how you get this carbon black, which is used as a pigment basically, or a filler. So we started to approach a friend of mine who was then working on making inks out of this. So he was sort of capturing this from a tailpipe of a vehicle.
Oh.
So we thought that why don't we use that as a carbon and then make bricks out of it. We were able to make it with the other waste that we put together. But we soon realized that we can't sell this. It's very expensive to capture this carbon, process this carbon, and then mix it with other ingredients and then be able to make it. Right now, you get bricks at scale which are cheaper. And if you have to sort of compete, you need mass scale to be able to build it. And still, it's extremely difficult to get it into a price point which will compete with that. So that's where we sort of realized that...
So they're just like really incredibly expensive to make and to sell?
Yeah. To give you a ballpark figure, it was anywhere between $45 to $50 a brick. And it was extremely expensive. No one's going to buy it.
How far can the story and the brand go if you can't make it economically viable?
We learned over here that what will people pay for? People will pay for design. This is the one point that we learned. And we want to leverage that. There's some value in design. And to leverage this, we then moved into a facade. It's an external skin of a building, capture the air pollutant and be made out of that. So we started to do this and we realized that, yes, we can make this. It is design. It looks good, decent, sexy. But would people really want it? Or do they really need it? And that's where the point came, is there commercial viability and scalability to this? And that failed again, because while we had design, it didn't have commercial viability.
So you can't scale it up.
Can't scale it up.
And then you go into tiles.
And then we moved from there. We started with tiles very specifically with these three factors. It needs to have design, it needs to be commercially viable at scale, and it needs to be a need-based product and not a want-based product. So everyone needs a tile, right? So every house has beautiful tiles. So can we replace them with eco-friendly tiles? So we then started with tiles. Back in 2019, May is when we were clear that yes, we can make these tiles. It could be low carbon intensive, using other waste and put them together. And there's a business case around it.
So I think now let's get into this tile and the making process. So what's the composition of this tile? Because it's very interesting, because you talk about carbon and I've seen some pictures also, they look lovely. So how do you get about sort of manufacturing these tiles? What goes into it?
So a tile right now, what we use as raw material is recovered carbon black. Essentially, this recovered carbon black comes from the tire industries. The tire, the end of life of a tire, it goes into a scrapyard, then into a recycling unit. which generates about 150 million kgs of waste, right? So even if we have EVs, tires are not going to die. And it's just going to increase more and more. But what do you really do with these tires? So there's this, after recycling, there is this recovered carbon black as a waste that comes. And this is being used as a cheap fuel right now. So we rather take that, which is otherwise burnt, we mix that with other industrial waste like marble chips, marble powder, stone dust, quarry dust, C&D as well. And then we make a paste out of it. And we compress it into a hydraulic press, and then we make these beautiful, gorgeous looking tiles that you see around.
When you started doing that, were you looking at other sources of carbon also?
We started to look at other ways of really looking at waste carbon that is already available in industry. So one of that is the tire industry. Second is we started to look at the stubble burning issue as well. So the farmers burning the stubble, we started to work with these partners who were telling these farmers, don't burn your stubble. You can put it into this machine. There's a carbon-rich byproduct that comes, and we can utilize this. So it's biochar, basically. We could utilize that. Or the third one was really the carbon which is captured directly at source or at from the tailpipe, or partners who are capturing directly from the outdoor. But that's more, so that's called black carbon, which is what you and me breathe, and that's soot in your lungs and my lungs right now. And the other is recovered carbon black and biochar, basically. So those are various sources of carbon that we saw. But along with that, we started to look at other industrial waste that is already there, which is otherwise going into landfill. So that's again an environmental impact that is having onto an industry. So we thought that why don't we mix that and then create a mix which is somewhere efficient in terms of cost, and then it creates a certain balance for us to be able to use it as a tile.
So I think when you're an architect, and of course you've had some amount of experience with the AA into material science, but there's still a gap that you sometimes feel with skills and with knowledge, right? So who do you look up to, and who did you look out for instance? Because you're trying to come up with this, there's a lot of science and technicality involved in this, right? So how do you find that, okay, there's this carbon, how can we make use of this?
See, it's a journey. I feel that while you are at it, you'll always find a million problems, I'd say. And there are, once you go out and talk about passionately about what you are doing, you'll attract the right kind of people who may want to be a part of it in some way. And that helps you sort of get some sort of network sort of to people, to talk to people. So there were a lot of people who reached out to us and they resonated with the idea that this needs to be done and someone needs to do it. So we got our mentor, which is Mr. 𝗗𝗂𝗄𝗿𝗂𝗀𝗃 𝗵𝗂𝗃. He's been working in the tiling industry very specifically. So he reached out to us and he's like, oh, what you're doing is really interesting, and we are building ceramic tiles, but this is also required, and probably this is the future for the next generation. So we got him.
That's amazing. I mean, they're getting actually incoming sort of interest into your product even before you've actually started making or selling the product.
Yeah, but on the same time, we were also reaching out to a lot of these technical experts that we knew from IIT Madras, from IIT Palakkad, from ISC, and lots of these institutions which we know that are experts in specific fields, very, very core to what they do, like material scientists. And they've done this. They know what it really means, what is the porosity, what is the binding strength, how do you use different materials to standardize it, what is the raw material character going to be, and what is this effect going to be, how much can you add before it starts to disintegrate. So the porosity of the tile is high, and what is the surface mesopores and micropores that are there, and we wanted to learn more about it. We reached out to various industry players who are, say, developing the sealants. Can we seal these pores and then there would not be stains? But we could not find a relevant sort of sealant to work with. That's why we reached out to Professor Ravindra Gettu in IIT Madras to understand how do we sort of work with this to be able to reduce that. So he's been helping us with reducing the porosity, various techniques that we can use, old and new, and how do we really merge it, do very in-depth analysis on that topic, and then learn about pores very specifically. So we had to speak to a lot of these experts, but eventually, I guess, you talk to 50 people, 2 people resonate with you, and then you start working with them.
What was the challenging part in all of this process as you were figuring out the right composition, the right size, or whatever? I mean, were there failures along the way?
Oh yes, definitely. You might have heard about 𝗗𝘂𝗿𝗀𝗀𝗃𝗃.
Yes, yes.
And we use that handcrafted tile quite a lot. We sat there for 3 months. We stationed over there. We started using those raw materials, and then there was a voila moment. Yes, this is possible. We can do it. But then you soon realize that it uses local materials, which is very local to 𝗗𝘂𝗿𝗀𝗃𝗃𝗃, which is 𝗗𝘂𝗿𝗃𝗃𝗃 sand as well. And there's a technical problem. Once you compress it, it's just, you push some like a metal on top of it, and then it stays like that for a certain period of time, and then you remove it basically, right? So after a certain point of time, like 2 years, 3 years, the edges wither off basically. So if the edges start to wither off, you start to have some sort of maintenance that you need to do every 3 years, 4 years.
So there's a geographical constraint on
to be able to do that.
And there's also the technical
issue as well.
Yeah, okay.
So we learned that, and then we told ourselves, okay, while we were able to do it, now we need to be able to create an advanced version of this. Let's see a raw material which is more decentralized, that we can manufacture anywhere. Imagine Delhi has its own manufacturing unit with its raw materials, which is used in Delhi. So that gave us sort of some hope that can we use raw materials which are more local. Then we changed our technique back again to more universal waste that we can use.
So your current setup is in Gujarat, right?
Yes, at this point in time.
So why did you choose to go to Gujarat for this?
Well, Morbi is the second largest tile manufacturing hub in the world. So it was for us a no-brainer, where we get the entire cluster of expertise around it. And Morbi also had the handcrafting artisans there, where there was this handcrafting machine that they used to use, but then it got defunct right now, and no one's making these tiles now. So we thought, let's reach out to them and try ask them, it's lying vacant, and why don't we sort of use that machine and generate revenue for you as well, and then we start making it from there.
So it's really interesting that you're using the handcrafted model and not a mechanized model in this day and age. So why that decision?
There's a thumb rule in our company. The way we say it is, if you can't make any product carbon negative, don't start at the first place. It needs to be carbon negative, which means that in the overall life cycle of a product, it needs to store more carbon than what it really emits. So we started to see that, okay, now we want to make tiles. What is the lowest carbon way of making it? It's handcrafting. Machines use a certain amount of energy as well, while those are scalable. So that's a trade-off to start with.
And you're also testing it out, and you're also testing how the market responds to it. Yeah.
And we don't know how much amount of capital that we are really going to need to be able to put this manufacturing unit. So can we start with something as a low capital expenditure and then test it out? So we started with this handcrafting technique in 𝗗𝘂𝗿𝗃𝗃, and then we moved into Morbi, where we checked there is a machine which can compress it. So we started to sort of look at that as a low carbon intensive way of making it.
And how was the response from the local community of sort of people that you were working with? Because again, like you said, this was something that it kind of lost over, some period of time.
So first, initially, there was a lot of excitement. Okay, this is coming back again. You're making it. But soon after, we mentioned that we have to use new materials and it has to be used like this. So there was a certain amount of hesitation to be able to use it. But then they understood the value in it, that we are doing this so that we can again revive this, but also use waste in a way that can sort of be reutilized into making buildings, basically.
I want to understand the composition of this tile. You said C&D and you said carbon. So roughly, like what percentages are we talking, and where are you sourcing all of this waste from? And is that an easy thing? Can you standardize it?
Yeah, so we moved from 𝗗𝘂𝗿𝗃𝗃𝗃. That was a major reason, right? We didn't want to use 𝗗𝘂𝗃𝗃𝗃 sand in a way which is more inherent to the entire base material as well. And now we are looking at more standardized waste, which is from the quarries that we take, which is marble chips, marble powder. So while we moved our base to Morbi, we started to look at Rajasthan and the entire quarry over there as a waste stream that we can get, like marble powder. It's a humongous amount of marble powder waste that you will find. So marble powder, we take marble chips, then quarry dust, quarry waste basically, carbon that we use, certain amount of cement that we use as well. And then we put that together to bind it, and then we make the tiles right now.
So now that you've made the tile, let's go to the next step, which is selling the tile. So how do you go about reaching out to architects, designers, developers, builders? Did that happen naturally? Was there interest already? Because I know you've been out there, you've been talking quite a lot about this. So did that happen on its own, or did you feel like you had to go out there and sell it?
So luckily or unluckily, I would say, we launched our tile in 2020 January, which is 3 months before pandemic hit India. And post that, it was, everyone knows it's just gone.
The world has gone dead.
Yeah. It's just been crazy after that. So we started to strengthen our supply chain totally and get our systems in place. But we got a lot of love because of COVID, because everything went online. People started to sort of see the way they were building. Conscious, say, consumption got a sort of a voice in a way. So people started to sort of cover us, media, and fortunately that we got a lot of sort of attention around that time. A lot of these architects started to reach out to us, brands started to reach out to us. Even today, we don't have the might to be able to go out and market ourselves. So we're utilizing this sort of the wave, tailwinds of all of that, and then see if there is interest. So we've been able to work with AIDAs, we've been able to work with Royal Enfield, Tata, we've done a pilot. Some architects are taking that bet as well with us right now because it's a new product. How is it going to fare? We have all the certifications that we really need to be able to do that, but it's a journey, I would say, and it will come together. But we need the entire architecture community to really come together and be able to support this eco-friendly movement.
So when you're working with architects and when architects are looking to integrate your product within their buildings and designs, right? There's two critical things that come into play. One obviously is cost. The second thing is design value. Like, does the design of your product align with their design approach? So how did you go about adding design value to this product?
As an architect, it allows me to think about how a project is being developed. Design, yes, of course, plays a huge role over here. And we made sure that we added, say, customization. You can add any sort of intricate design or a very contemporary sort of a shape and form that you would want onto the tiles. And meanwhile, along with that, now what we're doing also is adding more pigments. Apart from having black and white and grays, we want to add more pigments as well that can allow you as an architect to be able to experiment. But along with that as well, we had the plain tiles, which can become more affordable. So if you're using it, say, for like an office space, which is a huge area, you don't want a pattern tile everywhere. So we made sure that we had pattern, plain, pigments, all added to our catalog.
I've also seen some products that are almost art in nature, right? I mean, you're looking at these products almost as commentary on the state of the world today and, the challenges that we're fighting today. Talk a little bit about that.
So we started with making these tabletop experiments basically, and this is more for us. So we made these canvases, is what we call carbon canvas, and they're like these art pieces inspired from nature essentially. But more so, the idea was create an art piece that people would love to have it on their desk, have a starter for a conversation, and then maybe see where that can go. But that essentially has given us more orders as well now than the tiles itself, because anyone can buy just one piece as well. So we realized that there's a huge value in craft against climate change. Something that the craft itself inherently has, but then you give eco-friendly materials to work with this craft, and that can become a huge driver. For example, one of the design is reberb essentially. So it is an iceberg, so half up and half down inside. Most of the iceberg, which we don't see, is still inside, submerged inside the sea. And we don't see that. and how that can become like a karma for us, like how much of that we are polluting and how much of that is inside that we don't see as a soul. So we took inspiration from there.
I think another thing that comes to mind, when you look at something like this is how this can actually go mainstream. You're not limited by, let's say, your designs or your creative output here. You have a product and a composition that anybody can actually work with. So are you looking at making it more accessible to other people, other craftsmen, artisans, other designers to actually collaborate with you on something like this?
Yeah, of course. So that's the whole idea. I mean, we essentially see ourselves as enablers in a way. We want to democratize our material to be able to use by various people, in a way enabling them to make any art piece that they would want to, but using our mix. So imagine most of the handicrafts that you see, they are made with our material, which is eco-friendly in a way, but that also gives you a certain soul-filling souvenir.
I think beyond just soul-filling, it's also looking at, again, through the prism of, is it generating carbon emissions through the process of construction or the process of manufacturing? And sometimes what gets lost in our conversations is that some of these natural vernacular materials and techniques are actually carbon intensive. So how do you sort of break through that chain and bring in new ways and sort of new energy and new technologies into the system?
What is carbon emissions in a way? It comes from two parts. One is the process and the material mix that you have. So when we talk about handcrafting, there is the material, but the process is handcrafted, which means that it doesn't use energy. So our mind indirectly goes to a way that, yeah, it is handcrafted, which means that it has less energy. So it's more eco-friendly in a way. Yes, it is, but not from the process perspective. Imagine bleaching, imagine all those things. You use a lot of sort of chemicals that go into the water, it pollutes. So we need to be mindful about that as well. So what we are trying to do is we're trying to give this material to various people and then be able to sort of make handcrafted products as well, which will allow us to sort of scale to a large population, but also be able to make these crafts a lot more eco-friendly, which will have two impacts. One, environmental, but also social inclusivity.
When you're working with architects, obviously there's a cost factor that comes into play. So what price point are you currently aiming at for this style, and is it competitive in the market?
Right now it's very expensive, I would say. Any handcrafted tile is very expensive unless we don't mechanize and be able to reduce the energy on that as well. Right now we sell this at 175 to 300 rupees a square feet, which would be anywhere 4 to 5 times more expensive minimum from whatever people would buy. We want to bring this cost down to $100, where we see this is a middle class family also buys it at $100 or more as well. Some parts of it, maybe not all. And
especially if there's design value to it.
Yes.
Yeah.
Yes. So we can give people an option that if you were anyways buying it $100, would you want to buy an eco-friendly tile? And that option doesn't exist at this point in time. So we would want to give that option to a consumer. If they are doing, say, a 2,000 square feet space, would they want to change 10% of it to start with? That's a huge starting point because the tiling industry is massive. Even if you change 10% of it, there's a huge sort of a carbon emission saving that we would do.
So what's your goal or aspiration in the short term, let's say in 2 years with this product? Where do you hope to be?
We want to build a demo plant right now. Right now, everything is being outsourced, and that's one of the reasons we're not able to control costs. There's a certain amount of quality that we want to control as well. This demo plant will allow us to put all these systems under one roof, which is collect, process, build, cure, where we collect the carbon, we process this carbon, we build with this carbon, and then we cure it as well. So we want to put all of this under one roof and then eventually work with existing players and then scale using their entire distribution.
And you want to expand into other building products, because I know that's the vision that you began with.
The larger vision of the company is to be able to make carbon negative homes from where we started. And again, you can make carbon negative homes only if you have those products. So we start with tiles, which is more value based, which is design value, then move into price based products, which is blocks, panels, aggregates. it's also concrete that we are looking at. The point is, start with little, grow into it, get the expertise for it, and then move into scaling with that.
And what are the challenges that you foresee?
Major challenges, I'd say cost is one of the major entry barrier for people to use it. We see talent density. Talent doesn't exist for something what we are doing at this point in time. We also see capital that we require to be able to set up this manufacturing unit. It's very capital intensive. So these machines cost money, and without that you cannot change it basically. So there are challenges, but I would say that you go slowly, you solve one problem at a time, and keep your eye at the cost, I'd say. And if we are able to build a product which is at 100 rupees and on par with the existing building material, give the same qualities and the same features that they are giving, I think we'll be able to sort of sell it at scale. Another challenge that we foresee is water. The amount of water that we're using is a lot right now, because we were working with water curing and are at this point in time as well.
And that's similar to the way that concrete is cured?
Correct.
Okay.
So we want to change that, and we want to move into a CO2 curing carbonation technique basically. So it's a carbonation reaction. Imagine how a limestone is really formed. We use CaO as a base material. It reacts with moisture to form CaOH2. The CaOH2 reacts with the atmospheric CO2 to form CaCO3, which is calcium carbonate, which is limestone, which is what is naturally as a reaction happens, but it takes a very long time, decades and generations to happen, right? We are really making this sort of, say, conducive to happen inside the reactor, and then create this reaction in about 6 hours. So instead of 30 days, this will solve the problem and make this in 6 hours for us. And we'll be able to scale with this very, very quickly.
So are you saying then that the carbon dioxide is actually absorbed into the material?
Yes, it literally acts like the way nature does as a carbon sink. So it will be the CO2 gets stored in the tile. It gets trapped basically and gets stored. This CO2 can come directly from the air through a DAC system, direct air capture system, or it could also be from a flue gas, which is being let out from these chimneys, and then it can be reused into a tile.
So actually increasing the amount of carbon that you're actually capturing into the product then.
Yes, and it will be even more carbon negative while it also uses 0 liters of water in this entire process.
And how do you think the government can help in this process, or the industry can help? Like, where do you see, like, what are the top 2 things that, let's say, the industry or the government needs to do actually to make this or incentivize something like this? I mean, it's not just about you, obviously. It's about other startups and other sort of thinkers like you coming into the mainstream and disrupting it.
So there are 3 parts to this answer. One is the top tier, which is the government. There needs to be policies which are put in place so that we are incentivizing these kind of products to be utilized as well. Otherwise, no one wants to sort of go into the direction of making eco-friendly tiles or using as well. So incentivizing should start, and government has started in a way, I would say, but then it needs to be a lot more for people to be able to use it. 2 is these industries could come together and tell that, okay, now we want to move into this because there's this larger 2070 goal by India, which we have taken to decarbonize, and that can come together. It could also be architects, and architects really coming together and then creating this demand for eco-friendly products, which is, in my opinion, the single largest push that the industry could have overall.
And as you look to make the move at some point from handcrafted to semi-mechanized to mechanized, do you see AI playing a part in that process?
I think AI is a beautiful tool and we all should embrace it. Like it or not, it's going to be in our lives. Can you really imagine if we have something like Spotify of tiles? If you think about it, say every region has its own tiles, right? Like a design language to it. But right now we manufacture the designs and then it really is pushed into sales. But can we really know what needs to be manufactured based on the taste of a city and the scale that we are looking at? This could be then scaled into regions or states, which can have a similar sort of design language. We'd want someone to be able to do that, and so it solves a huge front-end problem.
So you're responding to the market and their interests. And also, I think it reduces wastage in a sense because you're not then producing something that will not be absorbed by the market.
Exactly, exactly.
So thanks, Tejas, for this conversation.
Thank you for having me.
So what we've learned through this conversation today is that while practices like carbon craft can create carbon negative building materials and solve one side of the equation, there's a critical need for architects and designers to create demand at scale to effectively decarbonize the built environment.